Okay. Yeah, we review a little bit. We talk about last week we talked about the definition of spanning set. Okay, so we have the vector space. We have this vector space V, right? And we have this set S, including the k vectors V1, V2, blah blah Vk. Okay, so S is a spanning set of vector space V if we can get the linear combination of all vectors in success S. Okay, so any vector V belong to vector space V. Okay, we can indicate vector V to become C1, V1 plus C2, V2 plus blah 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 plus CK, VK. Okay. Oh, I forgot to share with you one more thing. Okay, so according to the histories of ECE or EIT program, okay, the best student who got 1.3, okay, 1.3 is the highest score for histories of EIT or ECE program. Okay, and I hope, okay, yeah, this year's on, yeah, next year's, okay, we have the best student when they graduate, they get 1.0. Okay, I hope. Yeah, but 1.3 we have some. We have some. Yeah. Okay, so come back. Yeah, so we say the spanning says is span S. Okay, this symbol of spanning says is span S, or we say span V1, V2, blah blah Vk. Okay, yeah. We say S span V. Okay. Then we have the theorem we also discussed last week. So skip it. Okay. We have general procedures for identifying spanning set. Okay. Yeah. We have the success S. Okay. Containing W1, W2, blah blah WR. Okay. any X belong to vector space V, or we say X is the arbitrary vectors in V, okay, to be expressed by the linear combination of all vectors in the set S. Okay, we say S is spanning set. Okay, we need to demonstrate we have existing values of K1, K2, Kr, or we can calculate determinant. And if determinant is different from zero, that means we can get linear combination. Okay? Yeah. If determinant is zero, that means no solution. Okay? Is that right? So, example, determine to whether the set S spans B2. Okay? We have vectors by V is B2. So B2, that means A0 plus A1 x plus A2 x squared, right? This is the vector space. Okay? Yeah. So we have S. We have W1, W2, and W3, right? We have three vectors, right? The first one, the second one, and the last one. Okay? So any vector W's, okay, can be expressed by linear combination of this one. So we have C1 W1 plus C2 W2 plus C3 W3. Okay, or here they just say K1 K2 K3. Okay, so W is this one, right? Because W is the arbitrary vectors belonging to vector space V. So this is general, right? Okay, so we can get okay, vector W E K1 W1 times K2 W2 times K3 W3. Okay, and then after some modifications, you can get this one. You can get this one. Okay, so for this one, that means this coefficient equal to A. This coefficient equal to B. This coefficient equal to C. Okay, like this. Like this. Okay. So now we have K1 minus K2 plus K2, K3 is A. We have K1 minus K2 is B. We have K1 plus K3 is C. Okay. What is this? This is linear systems. The linear system, right? If this is a linear system, you can get augmented matrix. Okay, augmented matrix is what? 1 minus 1, 2, A. This is constant terms, right? Okay, we have 1 minus 1 and oh sorry, plus 1 plus 2 K, K3. 1 minus 1 and 2 B, 1 0 1 C. Okay? Yes, yes. Okay, so this is coefficient matrix. This is coefficient matrix. This one is augmented matrix. So if I say this one is A, coefficient matrix is A. Okay, so I try to calculate the determinant of A. Okay, do you know how to calculate determinant? Yes, from letter 2. Okay, so determinants of A is A0. Okay, that means no solution, no values of K1, K2, K3. So we say S doesn't span B2, or we say S is not a spanning set. Okay, yeah, you know how to calculate determinant? Yeah, okay, good. Okay, just skip it. Yeah. Do you understand? So this is the way to demonstrate any subset S is a spanning set or not. Okay. For example, this one is W1, right? This one is vector W2, vector W3, and this one is W4, right? Yeah, and then we similarly we have K1 times X plus X squared plus K2. What else? X minus X squared plus K3, 1 plus X plus K4, 1 minus X is what? A, right? A plus B, X plus C, X squared. Okay, yeah. So if I so we have K3 plus K4 times 1, right? And then we have K1 plus K2 plus K3 minus K4 times X. And then plus K1 minus K2 times X squared equal to here, right? And then you can get coefficients. Sorry, we can get augmented matrix. You get what? 0, 0, 1, 1, A, right? 1, 1, 1, minus 1, B. Then 1, minus 1, 0, 0, C. And this one is here. Something wrong? Let me check. Why we have a minus here? Help me to check. K3, 1 minus X. Any mistake? Any mistake? X plus X square, X minus X square, 1, 1 minus X, okay? So K3 plus K4. Okay? Yes? So I think... Sorry? K1 minus K2 X square, right? Why? This is K3, K4, right? Hmm? This one?
On the K3, 1 plus X plus the K4, 1 minus X. So you have to take
K3 plus K4 times 1, right? Yeah, correct. So the problem here. Yeah. Huh? Yeah, I hope. Okay, anyways, yeah, that's correct. Okay, yeah, anyway, yeah, you can calculate. Mm, You know, for this one, we cannot calculate determinant, right? Because this one is not a square matrix. We cannot use determinant. So we try to use Gaussian elimination or Gauss-Jordan elimination. Okay, yeah, try to determine K1, K2, K3, and K4. Okay, K3 and K4. Whether we have some certain values of K1, K2, K3, K4 or not. Okay, so this is your task. Okay, try to verify for yourself. Okay, yeah. Oh, I have some explanation here. Oh, yeah, I also recognize this one is wrong, and then and then I explained here. Oh my God, but I forgot because I lost of slides. Okay, sorry. So, so we have more example. Yeah, determine whether okay, the set S spans the matrix two rows and two columns, right? Okay, and we say this one is a vector to W1, this one is W2, W3, and W4. Okay, yeah. So you get K1, blah, blah, K2, K3, K4 equal to A, B, C, D. Yeah. So this matrix will be equal to this matrix. Okay, that means this element equal to A, this element equal to B, equal to C, equal to D. And then, yeah, very lucky because this one is a square matrix, so we can calculate determinant. Okay, and determinant is minus two different zeros, so we can get some solutions. Okay, at least one solution. Okay, we have one solution or many solutions. So we can conclude that S is a spanning set for this vector space. Okay, that's clear. Any questions? Maybe today we'll check attendance. Okay, some student cut class. Okay, of course. Okay, I seldom check your attendance, but sometimes yeah, many students cut class. Yeah. And then when they fail this course, okay, they see me and give me many reasons. Okay, maybe it's family problem, maybe it's accident, sick, not sick. Okay. Okay, so that's question B. Yeah, that's question B. So here, this is coefficient matrix. Okay, and we can recognize that we have the same row 2 and row 3, right? So we can conclude directly. Okay, determinant will be 0, and then S is not as many set, right? Easy. Okay, yeah. Theorem, we have two different subsets. S, we have V1, V2, blah, blah, VR, and we have S prime, W1, W2. Okay, yeah. So span S E spans S prime if and only if each vectors in SE, the linear combination of those is S prime. Okay, and each vectors in S prime is the linear combination of those in S. Okay, that means V1 is the linear combination of all vector here, V2 VR, and then we need to demonstrate back W1 is the linear combination of all vector in S, and W2 WK. Okay, so we say span S is equal to span S prime. Okay, so more example. We have vector space V. Okay, so vector space V is R3. Vector space V is R3. That means every vectors we have three elements, right? Three elements R3. R mean the elements will be real numbers, and three means three dimension. Okay, so that means if we have vector v1, we have three dimension 2 1 1. Vector v2, we have 1 minus 1 3. Okay, so if we have the vectors like this, you can use row vectors or row matrix or column matrix, right, to represent this one. Okay, but normally we use column vectors. Normally we use column vectors. Okay, of course you can use row vectors if you like, but normally we use column vectors. Do you know why? You know why? You don't know? I don't know too. You know, I know. Yes, of course. Right, correct. Okay. Because for linear combination, for example, we have C1 times V1 plus C2 times V2, blah, 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 right? So we have C1 and we have 2, 1, 1 plus C2, 1 minus 1, 3. Oh, sorry, minus 1. Okay, so that means C1 times 2 plus C2 times 1, blah, blah. Okay, this one like linear combination of vectors. Okay, this is a good way for you to understand the linear combination. That's the reason we use column matrix, right? Okay, so here determine whether the vector V belong to spanning set V1, V2. So now we assume S is spanning set, right? We assume S is spanning set, and we demonstrate V belong to S. Yes or no? Okay. So if you can demonstrate V equal to C1 times V1 plus C2 times V2, so V belongs to spanning set, right? Okay. So now the answers. Oh, they don't use C1, C2, they use A1, A2, so it depends, okay? So A1 times 2, 1, 1, plus A2 times 1 minus 1, 3 is 1, 5, minus 7, okay? And then we can get augmented matrix, okay? After that, we can get, okay, this one skip it because 0, so we have A2E minus 3 and A1E 2, okay? So we can include that V belong to spanning set. Okay, yeah. Is it easy? Any questions so far? Khoa, any questions? Do you have girlfriend now? Yes. Oh my god. Okay, yeah. Không biết sao giờ sinh viên yêu sớm nhỉ? Ha? Sao ha? Okay. I remember that I had a first love when I was in the final years of undergraduate program. That means 22 years old. Yeah. Now many students love too early. Okay. Ê, như thầy đang thắc mắc là như vậy mấy đứa yêu vậy rồi tình phí chia sao ta? Đúng không? Bây giờ cha mẹ cho tiền đi học được 35 triệu đi, tình phí chia cũng căng thẳng. Rồi tình phí chia sao? Như thế nào? Tình phí chia sao? Không kinh tế căng thẳng.
Hai chủ đề này hay mình thảo luận chủ đề tình yêu của thầy có một cái quy tắc ngầm là thường là những ai mà làm luận văn đại học với thầy là không có người yêu thầy cũng nhận. Yêu cũng nhận. Không tâm làm được, hoặc là phải làm sao cho thuyết phục được thầy. Thạc sĩ từ thạc sĩ trở lên có người yêu thì khuyến khích nhận, càng nhận, nhưng mà đại học có người yêu. Tại vì thầy rút kinh nghiệm mấy lần rồi, nó delay quá trời. Thay vì 6 tháng xong luận văn nó làm 9 tháng cả năm mới xong. Ta hướng dẫn nó mệt mỏi quá. Trừ khi nào mấy đứa phải thuyết phục thầy bằng cái bảng điểm rất đẹp, là hai đứa cùng nhau học gì đó chứng minh được thầy mới nhận. Mà bây giờ thì hết nhận luôn rồi. Bây giờ năm thì nhận 1-2 đứa là vui thôi. Bây giờ thế hệ trẻ bây giờ nó chọn những cái hướng nghiên cứu, hướng làm mì ăn liền dễ quá, làm thầy sợ ngán. Làm luận văn với thầy là bắt buộc phải 6 tháng và phải làm nghiêm túc, có kiến thức để chinh chiến. Còn làm mì ăn liền thua. Và làm với thầy phải đầu tư kinh phí. Tối đa là mỗi bạn làm với thầy là phải đầu tư 5 triệu. Thì các bạn sẽ đặt câu hỏi như vậy, 5 triệu đó làm gì? Dĩ nhiên là nhà trường sẽ hỗ trợ những cái thiết bị mất tiền để các em đo đạc, nhưng là lặt vặt ví dụ như làm PCB, mua điện trở, mua cầu dao, cầu chì, mấy cái electronic components thì mấy đứa phải trang bị. Chứ mấy cái lặt vặt mua vài chục ngàn, trăm ngàn phải tự đầu tư. Mà gom cũng nhiều lắm. Rồi làm thí nghiệm phải có bao tay, cách điện, rồi đủ thứ lặt vặt thôi đó. Rồi đôi khi mặt nạ, rồi tùm lum tà lưa. Làm PCB là đâu phải làm lần được đâu. Làm PCB là mỗi lần làm chục bo 500 ngàn. Nhà trường đâu có trả tiền. Nhà trường sẽ đầu tư những thiết bị như mấy cái oscilloscope đó, mấy cái dao động ký, mấy đứa biết không? Mỗi cái là khoảng 2 tỷ thì làm sao mấy đứa mua nổi. Thôi là vừa rồi thầy vừa mới reject một thằng làm luận văn đại học. Thầy nói là phải chuẩn bị kinh phí mua. Đó là thầy ơi mà nhiều tiền quá biến. Ít nhất phải biết lựa chọn thiết bị thế nào, mua làm sao, lắp ráp làm sao, đúng không? Đúng không? Được biết không? Chứ cái thầy ơi bây giờ thầy bỏ tiền thầy mua cho em con điện trở không có. Mấy đứa hôm nào nói anh Thanh là dẫn lên lầu 4 xem phòng thí nghiệm của thầy, xem mô hình thí nghiệm. Mô hình đó hiện nay chắc đầu tư khoảng 200 triệu. Tiền dự án của thầy có đầy đủ đó. Có BV, có sensor, cảm biến, Raspberry Pi, nó đủ thứ. Chiến. Còn lười biếng là thôi rồi, xong. Mà mấy công ty nó đặt hàng thầy giới thiệu người không có để giới thiệu, hàng hiếm. Giờ gọi bạn có Bảo Thanh nè, bạn Bảo Thanh là Bạn có TA nè, làm công ty XP Power, lương vào khoảng 16-17 triệu, chuẩn bị tương lai là lên Senior Manager. Và thầy khuyên là nếu lên được Senior Manager thì nên đổi việc, đổi công ty ở đẳng cấp khác. Không, nói thật, học rất là giỏi, tốt nghiệp hình như được 1.7. Tên là Dương Trọng Anh, bạn của anh Thanh. Anh Thanh là cũng một học sinh rất giỏi, được học bổng đi Hebron. Ngày ăn con buổi thôi, ăn buổi hả? Sáng cái gì hôm nào đó bệnh đi khám bác sĩ hỏi Bảo Thanh chích chưa, sáng rồi chích chưa, chích liệu nào chưa? Bảo Thanh không, quay lại câu chuyện để nói dốc rồi hết giờ. Okay. Hồi xưa học đại học thầy cũng nhớ đó, ở mo gầy mòn vậy đó. Mấy đứa bây giờ sướng rồi, bây giờ học đại học mấy đứa được tiền cha mẹ phụ cấp đâu ha, tiền phí tình yêu đủ thứ. Hồi xưa là sáng đi học, chiều đi học, về tối thì phải rửa chén, hủ tiếu gõ, rửa chén. Giờ 20.000. Mà không có xe ô tô thì tụi bay lái xe đi học rồi. Hồi xưa chiếc xe đạp Trung Quốc 150.000. Vô căng tin ăn quên khóa đi ra, của đi thay người mất mẹ xe đạp, lỡ bộ 2 cây số về nhà. Trên đường về khóc bù lo bù ly, tính cả rửa chén hủ tiếu gõ được bao nhiêu ngày để bù lại mua được chiếc xe. Khổ thế. Bây giờ sướng quá, ai ngờ ngon như bù mẹ chứ. Thôi không nhiều chuyện nữa, quay lại ha, rồi đi quá xa, khổ thế hồi vô câu chuyện. Okay, so coming back, so we have more examples. Okay, look at this one. We have vector space B2. Okay, yeah, that means we have A plus B x plus C x squared. Okay, and we have 4 vectors, so that means we have this set S. We have vector v1, vector v2, vector v3, and vector v4. Okay, yeah, and determine whether the vector v belong to the space S, okay, or not. Okay, so similarly, we need to demonstrate VE C1 V1 plus blah 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 plus C4 V4. Okay, yeah, and again and again, look at this one. This is not a square matrix, right? So we cannot use determinant to demonstrate whether we have the solution or not. So we need to use Gaussian elimination. Okay, so after that, you can see this one. You know, this is inconsistent because it's equal to 1. Okay, so we conclude that V's E not belonging to Spanish. Okay, yeah. Oh, many example. Okay, so for this one, what is it? We have the vector space. We have the vector space R3, and we have 3 vectors. That means S is V1, V2, and V3. To find out whether V1, V2, V3 span S or not. Okay, we pick any vector V, ABC. Okay, and determine whether there are constants R1, R2, R3 such that this one equal to. Okay. Yes, and yeah, when we indicate the linear combination, you can get this one, right? Yeah, A1 times 1, 2, 1, 2, 1 plus A2 times 1, 0, 2 and A3 1, 1, 0 equal to ABC. Okay, so that means you get 1, 1, 1 A1 but A2, okay, 2, 0, 1 1, 2, 0. Okay, yeah, and then we apply Gaussian elimination. You can get A1 is here, A2 is here, A3 is here. So ABC, they are real numbers. So that means A1 is also real numbers, A2, A3 the same. Okay, so we say that. Okay, we say that S
is a spanning set of vector specific, right? Do you understand? Yeah. Question.
Can we instead combine V1, V2, and V3 into like a matrix and then reduce row it so that we are only left with pivots?
Yes,
and
of
we
course.
count them?
Yes, of course, of course. You can do it. Okay. So if you practice more, you do more exercise, you can recognize the observation like the student said. Okay, we can combine V1, V2, and V3. Okay, you can get coefficient matrix. Okay, coefficient matrix. Okay, of course, this is observation. You need to understand for yourself. Okay, yeah, good, good. Okay, good thinking. Yeah. Do you understand his questions? Hmm? Good. So, yeah, we have many example. This one for your reference. Okay, samples for the final exam. Okay. For example, in each part, determine whether the given vector A in M22 belong to the spanning set A1, A2, A3. Okay, yeah, you need to demonstrate. Okay, A belong to spanning sets or not. Okay, yeah, very easy, right? Yeah, so that means we need to demonstrate A1 times A1 plus A2 times A2 plus A3 capital A3. Okay, and then we have linear combination. Yeah. Okay. And for example, here, which of the following set of the vector spans R4? So vectors V is R4. Okay. So here we have the set S1, this is set S2, set S3, set S4. Okay. Yeah. Yeah. So if we have S1, S2, and S3, we cannot apply determinant because it is not a square matrix, right? We need to apply Gaussian elimination. But now, very lucky, right? Because for the set S4, we have 4 vectors. And then you can get the coefficient matrix with 4 rows and 4 columns. Okay, so you can calculate the determinant. Okay? Yeah. So we hope for the final exam, we have the question like this. Okay? Yeah. No, for linear algebras, I will combine written exams as multiple choice. Okay. Yeah. Which of the following set of polynomials spans B2? Okay. Span B2. Yeah. Okay. So this is the samples of the final exams. Okay. Please take into account. Okay. Yeah. Of course, we studied before what is the difference between linear independence and linear dependence, right? Yeah. So if we have only trivial solution, yeah, we say we have linear independence. So if we have one solution or more solution, we say it's easy, linear dependence. Okay, linear dependence. Yeah. Look, a set of vector S, V1, V2, Vk in the vector space V is linearly independent when the vector equation, okay? What is it? This one lies homogeneous linear system, right? Okay. Have only trivial solution. That means all coefficients will be 0, and we can conclude that S is linearly independent. Otherwise, S is linear dependent. Yeah. Example, for example, this one. Sorry. So determine whether the set of vectors in R3, that means we have vector space is R3, linearly dependent or linearly independent. Okay, so we just demonstrate C1 V1 plus C2 V2 plus C3 V3 is vector 0, right? Okay, and if C1 equal to C2 blah 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 equal to CK are zeros, we say we have linearly independent. Okay, yeah, and then finally you can see we have C1, C2, and C3 are all zeros, so we say SE, the subset S is linearly independent. Okay, yeah, yeah. More example. Okay, now we have polynomial B2. Okay, B2. So we have the linear combination of V1, V2, and V3s are okay are zeros. Okay, is zeros, right? And then after that we can get C1, T2, and T3. Okay, we have the certain solution. Okay, so because we have non-trivial solution. Okay, non-trivial solution. So we say S is linearly dependent, right? Linearly dependent. Okay. Yes. Yeah, many example. Okay, just okay, remember that. So we have the properties of linearly dependent set. Okay, and we have corollary. Okay, 2 minutes or 3 minutes. Try to understand it. Very important. Okay, easy, right? Easy. Any questions? Any questions? Okay, so next slides. Very easy, right? Yeah, very easy. Okay. So if you just recognize the there's any in any vector vi in this set S, okay, E the linear combination of the order vectors or not. Okay, if yes, that means linearly dependent. Linearly, okay, it's a linear dependent. Okay, and this one, you know, is scalar multiplication. Okay, so of course, example. So we can recognize the V2A 2V1 plus 3V2. Okay, of course, very difficult to recognize it, right? Very difficult. Okay, so if it's difficult, we need to go back to the to these tips. Okay, we get the linear combination of all vectors. Okay, equal to 0, and then you find out C1, C2, C3. Okay. Yeah. Next. Okay. Testing for linear dependence of two vectors. Okay. So here, please tell me what is vector space. Vector space A are
R3, right? Because every vector has 3 elements, you know. Yeah. So this is linearly dependent because V1 and V2 are not scalar multiples, okay, according to the corollaries we discussed before. Okay, so this one is linearly dependent because V1 is minus 2 V2, okay? They are located in the same line. Okay, so we finish lecture 3 part 2, and remember that we have homework 1, 2, 3. That's all. Okay, and remember, submit your homework next week. Okay. Làm xong rồi hả? Làm xong rồi hả? Kinh hả? Các bạn mới học giỏi gì vậy? Tên gì vậy? Tên gì học giỏi vậy?
Không giỏi thầy.
Hả? Now we study lecture 3, part 3. Okay. We will discuss about the basics and dimensions of the matrix, the rank of the matrix. Okay, linear transformation. Yeah, we discussed a little bit linear transformations. Okay, least square we studied before. Okay, so we skip it. And application of vector space. Okay, 1, 2, 3, 4. Okay, 4 sessions of lecture 3, part 3. Okay. Okay. Yeah. So here we have definitions of the basics, okay, of vector space. Okay. Yeah. How can we know the basics of vector space V? Okay. Yeah. Look, we have a set of vector S. Okay, in a vector space V is called a basics of vector space V if the following conditions are true. Okay, are true. We have 2 conditions. Okay, first of all, S spans V. Okay, S spans V. That means we need to demonstrate SE a spanning set, right? And you know how to demonstrate SE spanning set, right? Okay, SE is a spanning set if any vectors in the vector space V is the linear combination of all vectors in S with the SE spanning set, right? And SE linearly independent. Do you know how to demonstrate S is linear independent? Yes. Okay. The linear combination of all vector in S, okay, equal to 0 vector. And then if we have trivial solution, right? Only trivial solution with S is linear independent, right? So if we combine 2 conditions, we can say S is the basics. This is the basics of vector space V, right? Understand?
Yes.
Yeah, good. So now, show us the following set is a basics of vector space R3. V is R3. So how many vectors we have? 3, V1, V2, and then V3. So we need to demonstrate S is linear independent. Okay. So the linear combination of all vectors is equal to 0 vectors, and then C1, C2, C3 are all 0. So we say S is linear independent, right? And S spans V. S spans V. Yeah. Yeah, of course, because this one is unit vector, right? This is unit vector, right? Or we can say this one is standard unit vector. Do you know what is standard unit vectors?
Yes.
Yeah, okay, we studied before. Okay, so the standard unit vectors, okay, this is the spanning set.
always, right? So here we say S is a basics for vector space R3. Okay, is it clear?
Yes.
Okay, good. Nói mà tôi mệt đó, tôi nghĩ 5 phút rồi, mệt quá. Dạ, mệt quá. Dạy sáng chiều, ngày có mấy trăm ngàn, mệt quá. You know, I teach full day, but the salary just little. You know, so I need to
Work for it.
rest. Okay. Any questions so far? Any questions? So later when we take a break, okay, TAs, please help me to check attendance. Okay, yeah, and yeah.
Check luôn bây giờ.
Thế luôn giờ hả?
Để cho mấy bạn lên.
Khổ thế, đi học mà còn phải thúc ép đi học ha. Sợ mới đến thi rớt, làm thầy sợ đủ thứ, sợ dạy dở sinh viên không hiểu, sợ sinh viên thi rớt thì chửi thầy. Đi học phải nhìn, xin lỗi, đi dạy phải nhìn trước nhìn sau, cái áo quần có rách thôi sợ sinh viên cười. Thế, đủ thứ hết chứ. Rồi dễ quá thì sinh viên ngọn đầu cổ, khó quá thì sinh viên nó chửi chù dập, đủ thứ hết chứ. Đóng học phí có 40 triệu học kỳ mà khó quá, cuộc sống khó khăn quá. Hợp lý không? Rồi chưa kể nó được học bổng, nó trả đóng tiền. Mà nó vô nó học nó như là cha là mẹ thầy, chửi rủa thầy dạy gì cho đóng textbook về đọc thấy mẹ luôn, biết có đọc không? Đúng không? Hồi xưa thì học đại học là giáo viên chủ nhiệm thầy học đại học là tư vấn tâm lý, là khi mà mấy đứa nhận cái điểm rớt, vì mấy thi cái môn mà đứa rớt thì thường sinh viên Việt Nam sẽ có câu là chửi thầy, má nó thầy cho đề khó quá, đúng không? Câu đầu tiên là mình sẽ nói như vậy, chứ chả có ma là nói má là tao học ngu quá nên tao gỡ. Khổ thế. Có ai tự chửi mình ngu mình nên mình rớt không? Đó. Hay là chửi thầy cho đề khó quá, kinh sinh viên vợ ghê. Hỏi ông Khoa, thầy nói đúng Khoa đang suy nghĩ đúng sai bứt tóc, đúng sai ngồi chọc lóc. Okay, so coming back, so now we find the standard basics. So we find the standard basics. Of course, okay, we need to understand what's the standard unit vectors. Okay, yeah. So for this is the standard unit vector, right? This is the standard unit vectors. Okay, so this is bending set, and of course S is linearly independent. Okay, so we say this one is standard basics. Okay, and then we have V is R3, so V R3, so we have 3 standard unit vector, right? E1 we have 1 0 0, E2 0 1 0, and E3 we have 0 0 1. Okay, so if we have V is R4, the vector space is R4, we have 4 standard unit vector, right? We have E1 is what? 1 0 0 0, and E2 blah blah, E3 blah blah, and then E4 we have 0 0 0 1, right? Okay, yeah, we said this is a standard basics. Okay, standard basics. Okay, non-standard basics. Okay, non-standard basics. This is the basics. Yes or no? I don't know. we need to check. Okay, we need to check with two conditions: S spans V. Okay, S spans V. That means we have C1 times V1 plus C2 times V2 is any vector V, or we can get 1 minus 1. Okay, so if you are familiar with linear combination, we just combine with the V1 with the V2, you can get coefficient matrix, right? Coefficient, and then we calculate determinant. Determinant A is -1, and then -1 you get -2. Okay, so this is spanning set, right? And then we need to demonstrate C1 V1 plus C2 V2 is 0. Okay, so you get 1 1 0 1 minus 1 0. Okay, so we can apply Gaussian elimination, right? So we can get what? This is R1, this is R2, right? So -1 times R1 plus R2 replace to R2, right? So we can get 1 1 0 0 -2 0, right? Okay, so that means C2 is 0 and C1 is 0. So this S is linearly independent. So we say S is the basics, right? And this is demonstration. Okay, yeah. So now we say SE a basics of vector space R2, right? Any questions so far? Yeah, good. Okay. Okay, this one to demonstrate SE is a spanning set, and this one demonstrate that S is linearly independent. Okay. So we have a basis for polynomials. Okay, the basis for the polynomial is here. Okay, 1x squared blah blah xn. So if we have bn, we can get this one is the basics. If we have b4, this one is the basics, right? b4, that means we have a plus what? A plus bx plus cx squared plus dx to the power of 3. This is coefficient, right? So we have 1x squared x3 here. Okay, yeah, for vectors in the basic S, let's just say S. Okay, and similarly we have the standard basics, where the standard basics of the matrix vector space of the matrix, 2 rows and 2 columns. Okay, so we have 1, the other will be 0 1, the other will be 0 1, the other will be 0 1. Okay, so this is the standard basics of the matrix. Yes, correct. Yes, correct. N minus 1. Okay, the textbook is stupid. Okay, no. Okay, no. Why? Because this one we can say this is b n plus 1. Okay, so I am stupid, not textbook. Do you understand? Yeah. So if here we say we have polynomial of n plus 1, you get x to the power of n. Okay, yeah. Can you get my point? Yeah. Okay. But normally we just say bn, and this one is. Maybe this one. Okay, this is wrong, right? This should be b1, b3. Okay, b3. Sorry, because this is to the power of 3. Okay, so I'm wrong. Did they be?
I think it's like the b and it has the highest power.
Yes. So this one is b3. So this one is bn. Okay. Oh, sorry. Here I say bn, but now I say it's b4. I'm stupid, right? I'm stupid. Yeah. Actually, it should be b3, right? Yeah. Okay. Sometimes I am also stupid. Okay. Yeah. Okay.
So we have a theorem. Okay. Theorem. So look, we have the success S containing V1, V2 plus Vn. Okay, is a basis for vector space V. Then every vectors in vector space V can be written in one and only one way as the combination of vectors S. Okay, yeah, that's correct. Okay, yeah. For example, here if we have the basics, this is the basic, this is the basics. Okay, so if we have the basics, 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 okay, any vectors in vector space, can be expressed by linear combination of all vectors in the basics. So this is the meaning of the basic, right? Okay. That means normally we can say the basics means the common variable. Okay, the common characteristics. For example, I would like to find a common characteristic of all students here. Okay, yeah. So any common points, any common features of all students here. Yeah, that's for example, we talk about the A level. Okay, less than 20 years on, right? Less than 20, right? Less than 20 years. Yeah, something like that. So this is the basics. Okay. Again, the basics mean any vectors in vector space V, okay, can be written in only one and only one ways in linear combination of all vector spaces. Yeah, right. Okay. Now we understand the basics. We understand the spanning set. We understand linear independence. Okay, right. So for some examples, yeah, for your reference, it's easy, right? Okay. Yeah. Now, theorem. Look, theorem. We have S. S is a basics for a vector space V. Then every set containing more than n vectors in V is linearly dependent. Okay, yeah. So if we already know the basics, okay, and we have other subset, and if other subset contain more n vectors in the basis, we say it's linearly dependent. Okay, or we can say the other subset is not the basis. Okay, so now look, R3, we have V is R3, right? So can we know the standard basics? Yes, okay. So S is E1, E2, and E3. This is standard basics, right? Because we know E1, E1, 0, 0, E2, E, 0, 1, 0, and E3 is A, 0, 0, 1. Okay, so this is already the basics. How many vectors we have? 1, 2, 3. And now we have another subset. How many vectors? 1, 2, 3, 4. Okay, so we say this is linearly dependent, right? Why? Because this is the basics. This is the basics. So S is linearly independent, right? Independent. And now here we have 1, 2, 3, 4 vectors. So of course this is linearly dependent. Do you understand? Yeah. So this theorem is very important. Okay, to help you determine whether the subset S is the basics or not. Okay, according to the standard basics. Okay. Now look at this one. We have B3. So if we have B3, so we have the standard basics. S is what? 1, x squared, and x to the power of 3, right? Right? How many vectors? 1, 2, 3, 4 vectors. So how many vectors is this set? 1, 2, 3, 4, 5. So this is linearly dependent. Okay? Yeah. So please remember, at home you need to summarize every lectures. Okay, of course we have more slides, but when you summarize just some A4 pages, okay, yeah, and you can remember for long times. Okay, one more. We have the theorems. 3 minutes. Brilliant. Okay, look, if a vector space V has one basis with n vectors, then every basis for V must have n vectors, right? Okay, yeah. And for example, this one R3, so yeah, of course we don't know okay, what is the details of the basics, but we know the basics should have 3 vectors, right? 3 vectors. This is the meaning of this theorem. Okay, so we know if we have the standard unit vectors, we have E1, E2, and E3. So now we count how many? 1, 2. So this one is not basics. You know, very quickly, maybe some seconds, you get the answers. Okay, and here we have B3. So we have 4, right? S is 1, x squared, and x to the power of 3. 1, 2, 3, 4, 5. Okay, stupid, right? So this is not basics. Okay. Okay. So we also determine the dimension of a vector space. Okay. Now we take break 10 minutes. Chứ không có điểm danh hai mấy đứa ha. Thầy ít